Hello, welcome back. In this video, we'll discuss the argon ion laser. Argon ion laser is essentially a gas laser. It is a gas laser of a special type. We have seen the helium neon laser where both helium and neon were taken in the form of gases. It's a gas laser. We have also seen the carbon dioxide laser where the carbon dioxide molecules, they are the active centers. And in the case of helium neon lasers, it is the neon atoms that are the active centers. Whereas in the case of argon ion lasers, it is the argon ions that are the active centers. That is a striking difference between the other gas lasers and the argon ion gas lasers. And the argon ion gas lasers are very powerful. They can give rise to outputs of hundreds of kilowatts of optical power. The argon ion laser is a gas laser in which ionized gas is used as the active medium or the lasing medium. Since it is a gas laser, the pumping method that we generally adopt for gas lasers is the electrical pumping. So, electrical pumping method is used. In the case of an argon ion laser, the argon gas is taken in a discharge tube. The population of higher energy levels increases due to the successive collision of the atoms with the electron and also the ions with the electrons in the discharge tube. Like in the case of other gas lasers, here also we'll be using electric discharge to supply energy to the active medium. The electric discharge causes the flow of electrons within the discharge tube, and these fastly moving electrons, they interact with the argon atoms and make them ions. Collision between the argon ions and the electrons will make the argon ions to go to the excited states, and these excited states will have a population inversion for the argon ion with the lower energy levels. Since these lasers are powerful lasers, the lasers require high pumping power. These lasers require high pumping power. Generally, it will be in kilowatts. Reason is electrons should interact with the argon atoms to give rise to argon ion. Further, the interaction of the electrons with the argon ions will produce the excited argon ions. So, in these two cases, the kinetic energy of the electrons is used to knock out an electron and to produce an argon ion, and also to excite the argon ion into an excited argon ion. That is the reason why we need high pumping powers. These lasers can be operated both in pulsed mode as well as in continuous wave mode. Now we shall look at the construction of the argon ion laser. The argon ion laser consists of a very narrow discharge tube. The discharge tube is generally made of beryllium oxide. A narrow discharge tube made of beryllium oxide filled with argon gas is used. So we have the anode and we have the cathode. They are connected to the DC power, and we have the gas supply. We have the coolant because the argon ion laser can produce temperatures up to 3000 Kelvin. So we need to cool down the laser. We use water cooling. So cooling water is sent inside the laser through this pipe. Water outlet comes from this, and this tube is surrounded by two reflecting mirrors. One is output coupler. This is a 95% reflecting mirror, and only 5% of the light can transmit through this mirror. And we have here another mirror that is 100% reflecting mirror. Between these two mirrors we have a prism here. We use a prism because the argon ion laser can be made to operate in two different prominent wavelengths. In order to choose one of those wavelengths, we use a prism. The beam emerging from the prism will fall perpendicularly on the 100% reflecting mirror. That particular wavelength only will be reflected. The other wavelength will make certain angles with the mirror. As a result, only the one wavelength that is chosen using this particular angle of the prism and the mirror will have sustained oscillations in the optical resonator. This magnet enables us to focus the argon ions concentration along the axis of the discharge tube. We have two mirrors are used in argon ion laser. Say this one M1 and this one M2. M1 is 100% reflecting mirror while M2 is 95% reflecting. Thereby a fraction of the energy can emerge from the M2. From here only we get the lasing. This is the laser. When high voltage is applied, the electrons will move towards the anode and the argon plus ions they move towards the cathode. In doing so, some of these argon ions they will be neutralized near the cathode and slowly they will be diffused into the discharge tube. The neutral argon atoms will diffuse into the discharge tube. Due to the presence of the magnetic field, only the argon ions will be available along the axis of the discharge tube. When high voltage is applied, a high current flows through the discharge tube, and this current produces the argon ions and they migrate toward the cathode and the electrons toward the anode. Argon ions having low mobility tend to accumulate at the cathode and get neutralized. Eventually they diffuse back into the discharge tube. The electric field in the discharge tube accelerates the ions, thereby the fastly moving ions they produce very high temperatures of the order of 3000 Kelvin. Since these ions can collide with the tube, thereby the tube can get damaged, we use a magnetic field to improve the density of the ions along the axis of the tube. Magnetic field is used to increase the availability of argon ions along the axis and to reduce collisions with the walls of the tube. The argon ion laser oscillates simultaneously on two different transitions having wavelengths 488 nanometers and 514 nanometers. This is a blue color laser and this is a green color laser. The argon ion laser can emit simultaneously these two colors. In fact, the argon ion laser can emit up to 18 different wavelengths. However, these two wavelengths are prominent. They are the strongest lines in the spectrum. The intensity of 488 nanometers and 514 nanometers is almost same. That is the reason why we use a prism in the argon ion laser to tune it to operate either in this wavelength or in this wavelength. Argon ion laser is made to operate at a wavelength, tuned using the prism. Now we shall look at the electronic energy levels involved in the argon ion laser. The argon ion laser is a 4-level laser. Energy level diagram of the argon atoms and argon ion. E0 is the ground level of the argon atoms. When the argon atoms interact with the fastly moving electrons in the discharge tube, they will be excited to the ground level of the argon ion, that is argon plus. So E1 is the ground level of argon plus ion. The collision of the electrons and the argon ions will make the argon ions to go to excited state, which consists several energy levels. We call those excited levels as E3. E3 is the pumping level and a metastable state. So a transition from E3 to E2 energy levels. E2 energy levels is a group of energy levels. A transition from E3 energy levels to E2 can give rise to 514 nanometers or 488 nanometers. From E2 to E1, it is a radiative decay at 72 nanometers. And again from E1, it will be neutralized. We get the argon atoms. Here, argon atoms are excited to argon ions, and argon ions with the kinetic energy of the electrons, they go to the excited state. And from the argon ions, we get the lasing. So this is a transition from E0 to E1. And this is a transition from E1 to E3. E3 is the metastable state. E3 to E2 is a lasing transition. E2 to E1 is a radiative spontaneous process. And E1 to E0 is neutralization of argon ions. Now we shall look at the important features of the argon ion laser. It's a 4-level gas laser. Argon ions are the active centers. It can deliver several kilowatts of optical power. It's a tunable laser. The beam divergence of argon ion laser is very small. In this video, we have started our discussion by stating that argon ion laser is an ionized gas laser, and we use electrical pumping method to supply energy to the argon ions. And argon gas is taken in a discharge tube that is made up of beryllium oxide. The argon ion laser can produce several kilowatts of power. Argon ion laser can be operated both in continuous mode and the pulsed mode. We have seen the construction of argon ion laser. We have said that argon ion laser can produce two different wavelengths, namely 488 nanometers and 540 nanometers. Argon ion laser can be tuned using a prism. We have seen the energy level diagram of the argon atoms. We have seen the excitation scheme in argon ions and also the lasing mechanism. We have seen finally the features of argon ion lasers. Thank you.